All right, good afternoon. Welcome back to Introduction to Statistics. We are talking about section 7.3 here. All right, so this is how you do one of these problems. Okay, it's not nearly as intimidating as the intro led you to believe. So it's pretty much the same kind of thing we've been doing in 7.2 with a little twist to it. Okay, so here we go. And I'll call your attention to the spots that are different. We have the mean annual income for people in a certain city is 45, so it's $45,000. Standard deviation of 33. Okay, and a pollster draws a sample of 92 people to interview. Okay, so what we're going to do is we're going to ask questions about like what is the probability that the sample mean this 92 people, right? What is the fact that their average is less than 40? Okay, so how do we know? Because notice they didn't say anything like the normal distribution. They didn't say that. Okay. So is this distribution normal? Why? The reason why is because 92 is a bigger number than 30. 30 is the cutoff. If you don't have 30, then you're kind of stuck. Okay. If you know that the underlying distribution is normal, then you don't need a minimum sample size. It's automatically normal. So you think about it as like inheritance, like your group distribution, inheritance distribution from the individual. So it's kind of a thing like, look, if your parents can't have children, then genetically you can't either. Okay. So we have an annual income of $45,000. We have standard deviation of 33. Pollster draws 92 people for the interview, and we want to know what is the probability that the sample mean income, so the group of people have a mean of less than 40. Okay, so what we're going to do is we're going to have our distribution here. We still have the average. Okay, again, the average of the averages, the average of the average is the average. Okay, so we're still going to say that this group, this X bar, has a normal distribution and that its average is 45. But the standard error here, we're not going to say standard deviation, we're going to say standard error, is still going to be, it's going to be 30, it's going to start with 33. But what do we have to do? We have to say divided by the square root of how many people did we poll? We polled 92 people. Okay, so the standard deviation, the standard error is going to be 33 divided by the square root of 92. Okay, and they want to know, okay, what's the probability that this group of people had an income less than 40? So this is 45. Okay, and it's going to be a little bit tighter than what I usually draw for my normal distribution. It's going to be squeezed a little bit, but they're going to come here and they're going to say, okay, let's look at this one. And they want to know what's the probability that this is less than 40. Okay. So what we're going to do is we're going to go to our norm because we know it's normal because there's more than 30 of them. We're going to go to norm CDF. Okay. And then just for the sake of argument, we don't need to keep this number, but just so we can kind of get an idea of where we want to, how we want to set this up. Okay. We're going to say, I want 33 divided by the square root. Okay. That second function, the squared button, the square root of 92. Be careful with your parentheses. Be careful of doing all of this. Okay. And then equals, and we have a 3.44. Okay. 3.4. So that's our standard deviation effectively for this distribution is about 3-ish. Okay, so we want 45,000 or 45 with a standard deviation of about 3. Okay, and they want to know, well, how many people make 40,000 or less? Well, that's like a 1, maybe 2, if I say 45 minus 6, that's close to 40. That's close to about 1 standard deviation below. Okay, so if you remember that 1 standard deviation below. Okay, so again, we're still going back to empirical rule, right? 1 standard deviation within 1 standard deviation was 68%. How much is outside of that? So 1 minus 0.68. Okay, just going back to empirical rule. Hopefully that's making a little bit more sense now. That this in the middle here, this is 0.32. Okay, this is 0.32% in the middle. How much is outside of that? So let's say 1 minus 0.32 should be like, okay, 68. No, sorry, this was 68%. 1 minus 68 was 0.32. I'm sorry, this was 68%. Okay, and then I've got two pockets. I've got 30, so $1 minus 68 cents, that was 32 cents. Now I'm going to take my 32 cents and I'll put it a little bit in my left pocket, a little bit in my right pocket. How much if I want to divide that evenly? We're going to put about 16 cents in each pocket. So each of these wings here is going to be about 16%. Okay, 16%. So we're going to say 45 minus 1 standard deviation. Okay, so this was about 3-ish. So 45 minus 3 is 42. Okay, so less than 40. Okay, I could say that's going to be like 16%, but not quite. Okay, we're going to pause for a moment. Oh, no, where were we? We were going to calculate a probability. We were going to calculate the probability that this average this average group of people, 92 people in all, that their average income was, let's see, their average income was less than 40. Okay, so here we go. Here's the 40. Okay, the average income for everybody is 45. So let's go ahead and draw that out. Okay, so here's 45. Okay, here's my 45. And if they want to know what the average is less than 40, so they want to know this shaded area right here. Okay, so the way we do that, we know it's normal because n is a big number, right? N is bigger than 30. Okay, 92 is bigger than 30. So what we're going to do is we're going to type in, okay, CDF distributions, probability CDF. Okay, we need a small number. Okay, so something that's relatively small. Something, if you look at average of 45 in various different steps, okay, our step is going to be, what did we say, was 33 divided by the square root of 92. That's like 3. Okay, so if I do, again, if I make $45 a week and I've got to figure out like, well, how long, if I've got a gambling problem and it costs me about $4, okay, somewhere between $3 or $4 every week, how many weeks is it going to take for me to go broke? Quite a few. So we'll type in 0, okay, as my low number. So same as before. 40, okay, what's my average is 45. Okay, that's what we kept that with. Okay, that's 45. And now what we're going to do is we're going to say comma, okay, and I want 45. And I want 33 divided by the square root, okay, the square root of 92. And you know what? The calculator is going to take care of all of that. We don't have to make a different entry. We don't have to separate this into 2 lines. We just draw it in as 1 line, and it's going to do that for us. Okay, don't forget the parentheses. Do one more just to make sure. And we got 0.07. Okay, so that's what we're looking at here. And it's going to be a little lower than I thought. So I thought maybe 16%. It's going to be lower than that. So we got 0.0731 as our 4 decimal place approximation. So we're just going to type that in. So 0.0731. Okay, we'll go through and check that. Right, I should have put in the 0 place for a leading 0. Okay, what's the probability that they have an income at this group? Remember, it's the group of people, it's the group of 92, that their average income is between 41 and 47. Okay, so here is our 45. Okay, we have our distribution, and they want to know between 41 and 47. Okay, here's 41. Here's 47. They want to know, what is this probability here? All right, and we'll see what happens. So let's go ahead and hit second function, distribution. Okay, and they told us what the low and the high number are in this case. So it's a little bit easier of a problem now. So we're going to go from 41. Our high number was 47. Okay, our average, what's our average? 45. We're at 10.45. Okay. And our standard deviation is going to be 33 divided by the square root of how many people were there? 92. Right? I'll put another parentheses in there. I don't think you have to do any parentheses. I think it'll just do it, but I just want to be sure. So we got 0.5659699. So to 4 decimal places, let's call this 0.59. Let's call it 70. So 0.597. Okay. So we'll go ahead and say that. So what? 0.597. Okay, we'll check. Hooray. Okay, so the next one is, again, they asked us, like, what's the probabilities between this number and that number? Now, this one, they want to know, what's the 10th percentile? Okay, now, usually in a face-to-face class, like I had to do this with tables, this is a little bit harder with a table. The calculator takes out all the heavy lifting, so we don't have to worry too much about that. But what we're going to do is we're just going to come over here, and we're going to say, okay, well, we have norm inverse. Okay, so what's happening is we want the 10th percentile. Right, here's 45. We want just this little bit over here, and we have this different standard deviation, right? This is 33 divided by the square root of 92. That's our standard error, okay? Or sigma with a little x bar as a subscript. That's another way they write it. But it's this number has the job of the standard deviation. Okay, it's referring to a statistic, the mean, the sample mean. So we call it standard error to differentiate it. But effectively, you can think about this as a standard deviation. And just remind yourself, like, oh, it's the standard deviation of a statistic. So we call it standard error rather than standard deviation. That's the only difference in there. I know that they make it really complicated for that, but that's just all we're doing. Okay, so because we have a name for everything, right? No, not everything. So we're gonna go to norm or INV norm. Okay, what's the probability? It's 0.10. Okay, what's our mean? Our mean was 45, and our standard deviation was 92, divided by the square root. Okay, divided by the square root of. That's not right. How about we double check our standard deviation here? Okay, standard deviation of 33 divided by the square root of 92. Okay, like I said, the calculator takes care of all the heavy lifting on this. We don't have to remember how to do standard deviations like this. We're just going to do that. And we are getting, okay, the lowest 10 percentile, right, is 40.6. Okay, how many decimal places do they want for this? Like that here. To at least one decimal place, they want 40. They're going to say 40.6. So if you can imagine, like these 92 people, maybe they're gathered at a cocktail party or something like that, and they're all bragging about their income, and one of them says, "I make $40,000 or almost $41,000 a year." Like, dude, you're in the bottom 10 percentile here. This is not something you should be bragging about. Okay, but it's out of that group that happens to be there. Okay, that's not for everybody. That's not an individual. That's for that group. So if this person is flexing their $40,000 or $41,000 a year, like in that group, like you're in the 10th percentile. Okay, it's actually, I'm not saying that right. A small group of that group says that our average was 10. So that they average for that 96, for that 93 people is going to, or the 92 people rather, has to be this value to be in the 10th percentile. Okay, so we're talking about this 92 people, their average. Okay, if their average is less than 41,000, that group of people is in the lower 10th percentile. And later on, we're going to use that for like, well, what if these people didn't have a bachelor's degree? Or what if these people worked in a particular field? What if they were all healthcare workers and they were all getting shafted by the medical industry that was paying them less? Okay, that's how you would tell. Okay, so we're going to say this is 40.6. Okay, so you're eventually going to be looking for commonalities between this group of people to see if these people as a group are suffering any particular thing. Okay. And that's how we're going to see that. Okay. Using the cutoff of 0.05, of course. Would it be unusual for the sample mean to be less than 33? I'd say yes, because look, the 10th percentile is 40 and they want to do less than 33. So yeah, it's going to be unusual. Okay. We're going to calculate it anyway because they're going to ask us for a probability. Okay. So we're going to say norm. They want a low, a high, a mean, and a standard deviation, a standard error in this case, right? Because we're talking about a group of people. We're talking about this average that we want to deal with. Okay, so we need a low number relative to the mean of 33, okay, or mean of 45, sorry, with standard deviation of 92 divided by 3.3 divided by the square root of 92. Okay, whatever it is. Yeah, standard deviation of 33 divided by 10-ish. Okay. So yeah, a small number for that is going to be like 0. So we could say norm CDF. Again, I'm picking numbers that I wanted that are easy to plug in. Okay. And then what was the high value that we wanted here? Less than 33. What is our mean? Mean is 45, wasn't it? And then our standard deviation, that was 33 divided by the square root 92. And it's nice that the calculator does this, but way back in the day when I would write these problems, I would have, instead of 92, I might pick something like 81, because when you take the square root of 81, it just get 9. So it's easy for students to remember that and put that back into calculators. Maybe I would have picked 100, so it would have been easy for students to pick that number back out. Okay, but they use the calculator now. You don't have to worry about that. And I generally grab the problems out of the book rather than modify them. But if this was a in-class type of a test, we weren't doing this, I would take that standard deviation and change it so you would read it in the problem, be different, okay? And the standard deviation would be something that's going to have a nice square root, okay? So we're going to go here, norm CDF, okay? And we're going to go from 0, there we go, 0 to 33, because that's what they wanted. They wanted less than, probability that it was less than 33. Okay. Yeah. Okay. Our average was 45, so this is considerably less than the average. Okay. Comma, 45, comma, and what was our standard deviation again? I don't know why I can't hold this number in my head, but I'm not able to do that right now. So standard deviation of 33 divided by the square root. Okay, divided by the square root of 92. All right, go ahead and hit that. It's going to be a small number. Okay, there we go. So yes, this is Okay, let me go ahead and do this. This is 2.43, we'll say 4348 times 10 to the negative fourth. Okay, that's how this is. So really what we have to do here is take this decimal place. So let me move it over here, 2.4348 times 10 to the negative fourth. This is 1, 2, 3, 4. So 1, 2, 3. We put the decimal place here and then there. Okay, this is 2/100ths of a cent. Okay, so is it less than a nickel? Yes, by quite a bit. Okay, so we're going to go back here to say, yes, it is unusual because the probability is, and I wonder what they'll let us type in. Okay, we'll type in 2.4348, and then we'll say capital. Well, they won't let us do E. Okay. Don't type in 2.48. I'll mark you wrong. I will take off extra points because your probabilities have to be somewhere between 0 and 1. Okay. So we're going to say 0.0002. Okay, and that is the rounded off decimal place, 1, 2, 3, 4 decimal places. Okay, paper pencil test, I would expect you to write this, but it's important to know that you have to remember that E-4 when you have a paper pencil test, okay, because that's what's telling me where the decimal place is. Don't just type in 2.43 and then be done with it. That's the wrong answer, okay? And that's actually with face-to-face class, that's extra wrong because you know better at this point. Probabilities have to be between 0 and 1. Okay. Using a cutoff of 0.05, would it be less than? Yeah. Oh, would it be unusual for an individual? Okay, now notice what they've done here. They've changed this. They said, explain, assuming the variable is normally distributed. They didn't tell us that before. How do we know it's normal? Because n was greater than 30. Now they're going to tell us that this is a normal distribution, so it doesn't matter. So now they're asking about an individual. So we turn this back into a chapter 7.2 problem rather than a chapter 7.3 problem. Okay, so all we're going to do is figure this out for less than 33 for an individual. Okay, so we just want norm distribution, so norm CDF. Okay, 0, 33. What was our average? It was still 45, but in this case, what's our standard deviation? Okay, we go back up here and say our standard deviation, if it was just one individual, standard deviation is just 33. Okay, and that's actually like one standard deviation down. That's actually going to be a pretty big probability comparison. So instead of 0, because we get to take steps of 33, like if you started at $45 in your savings account and you were losing $33 a week, how long is it going to take for you to go broke? Not too damn long. Okay, so why don't we put in like norm CDF, pick something where it's going to take a while for you to go broke if you're losing $33 a week. If you started with $45 in your savings account, how about we go with negative 1,000? Okay, and then we're going to go up to 33, 45, 33. Okay, something strikes me as terribly. Oh, wait, why do I have an extra 43 in there, 33 in there? 33 here. Okay, let me double check to make sure my standard deviation is what I think it is. Okay, so we go back up here. Standard deviation was 33. I don't like the fact that he put so many 33s in his problem, but so be it. Okay, but because we're talking about an individual, the standard deviation stands at 33. We don't worry about it. Okay, no square roots. So here we go. Second function, distribution. Okay, norm CDF. Pick a relatively small number, starting from 45, counting down by 33s. So we're going to pick negative 1,000. Okay, comma 33, that's our big number. Okay, what did we start with? We started with 45 as an average. I think 45 is an average. Why do I have 40 written there? Okay, we're just going to double check this to make sure we have 45. Okay, that's the average. And we're just assuming that instead of 92 people, it's just one person with exactly the same scenario. Okay, and then comma 33. Okay, so it's going to be quite a bit bigger of a thing. Okay, so it's about 35%. Okay, so we have 0.3581. Okay, so 3581. So we're going to say 0.3581. It would not be unusual. Is that less than a nickel? No, that's considerably more than a nickel. So no, it's not that unusual because the individual income less than 33 is about 35%. Okay, 36%. Okay. We got our green flag, so we're good to go, and I'll see you on the next problem. Okay, so thank you for tuning into that one. This is 10. I did 10. Okay, problem number 10, so be it. Okay, so this was problem 7.3, number 10. Okay, good enough. So a little bit out of order, that's okay. They're all good. All right, thank you for tuning in. I'll see you next video.